Hello everyone. Last time we discussed plotting horizontal and vertical lines. Today we will be discussing how to plot more general lines by making use of linear equations in the slope-intercept form. To begin, let's go over this slope-intercept form. This is the form of linear equations we see the most often, and it looks as follows. We have our dependent variable y equal to some constant, which we will label m, multiplied by our independent variable x, plus some other constant, which we will label b. This form is referred to as slope-intercept form, as the m here is the slope of the line, while the b is the y-intercept. So we have slope-intercept form. Let's review what these terms mean. The slope of a line represents how steep the line is, and is often thought of as rise over run. That is, we think of how much the line goes up or down in y between any 2 points as the rise, and how much the line goes left or right in x as the run. Let's say we were looking at a grid here, with 2 points on our line here and here. So the line is going like this. If we start from the leftmost point and go to the right, which is typically how we read lines in increasing x, how far we go in x will be the run. Since the x values from left to right are increasing, our run will be positive. Let's count how many times in x we moved to the right. In this case, we moved 3 units to the right. We will then follow the line to determine how much we have gone up or down between these 2 points. Since we started from the left point and going towards the right point, we'll have to be moving downwards, and this distance will end up being the rise. We see that we move 2 units down, so our rise in this case will be negative because of the down direction, and then 2 for the 2 units. We can then interpret our slope as rise over run, which in this case will give us the rise -2 over the run 3, or -2/3. In general, the flatter a line gets, the closer the slope gets to 0. On the other hand, the steeper a line is, the further from 0 the slope gets. In addition, lines that are increasing in y as we go from left to right, such as these, all have positive slope, while lines that decrease in y as we go left to right, such as these, all have negative slopes. We will also go ahead and note that horizontal lines, which are flat left to right, have slopes that are equal to 0. Meanwhile, vertical lines, which go straight up and down, have undefined slope. Next up, let's understand what we mean by intercept. Recall that our Cartesian coordinate system has an x-axis and a y-axis. Anytime a curve or line touches these axes, we call that an intercept. So for this line here, both of these points would be intercepts. We can also distinguish these intercepts based on which axis the intercept is on. If the intercept is on the x-axis, such as this one right here, we refer to it as an x-intercept. These x-intercepts always have a y-coordinate of 0, because they are on the x-axis where y equals 0. On the other hand, the intercepts that are on the y-axis, such as this one here, are referred to as the y-intercepts. And these y-intercepts always have an x-coordinate of 0, as they are on the y-axis where x equals 0. It is these y-intercepts that appear in our slope-intercept form, where the b is the y-coordinate of the y-intercept. We can see this by simply plugging in x equals 0 into our general equation here. When we plug in 0 for x, we will end up getting m times 0 is 0, and are left with just y equals b. So 0 comma b is a point on our line, and since it is at x equals 0, this is our y-intercept. Now that we understand slope and intercepts, let's see how we can use our slope-intercept form to quickly plot our lines. Consider the equation y equals 3x minus 1. Rather than making a table of values and getting points to plot, let's read information directly from our equation. Based on what we just learned, the -1 here is the y-coordinate of our y-intercept. So we can go directly to the value of -1 on our y-axis and plot a point there. All we need now is one more point to form our line. To get that next point, we will make use of the slope, which from this equation is 3. This 3 can be written as a fraction, 3 over 1, which we can think of as the rise over run for this line. What this tells us is that if we run 1 unit to the right, we should rise 3 units up in y. So starting from the y-intercept point, going right by 1 and up by 3, we end up here, where another point on our line should be. Now that we have 2 points, we simply connect them with a straight line, and there is our graph. Let's discuss one more example to make sure we have this process down. Consider the equation y equals -2/3 x plus 2. Using the same steps as before, we see that the plus 2 here will be the y-coordinate of our y-intercept. So we'll go to the value of 2 on our y-axis and just plot a point there. For our next point, we'll be looking at the slope, which is the -2/3. Thinking of this fraction as rise over run, we need to pick which number we shall attach the negative to. I will go ahead and attach the negative to the 2 that's on the top, making my rise -2, while my run should be +3. Starting from my y-intercept, I have a run of 3. So I'll move 3 units to the right, while my rise is -2. Because of the negative, I will be rising downwards, so I'll go down 2 units, and end up here, where my next point should be. Then just connect the dots, and we are done. With this, we have discussed the slope of a line, as well as the x and y intercepts, which come into play in many more types of graphs. We have also seen a quicker method of plotting linear equations, which should not only speed up the graphing process, but also help visualize these lines simply by looking at the equations. Until next time.